Welcome to today's lecture on multiplying and dividing of fractions. I'm Drew Collop. We will start with multiplying of fractions. There's a process involved in that. It's quite a bit different than when we were adding and subtracting of fractions. First of all, we do not require common denominators. This, in a sense, is much easier than adding and subtracting of fractions because we do not require to have common denominators. There's a process in place. Let's go through it now. Step number 1. Change any mixed numbers to improper fractions. Hopefully you've had a lot of practice at this and you've gotten quite good at it. Next, change any whole numbers into fractions by placing them over a denominator of 1. We then multiply all the numerators together, and this new value of multiplying all the numerators together, this becomes the new numerator. We then multiply all the denominators together, and this new value becomes the new denominator. Finally, as always, see if we can simplify our fraction. Again, common denominators are not required. Let's look at our first example here. Here we have 2 over 5 multiplied by 3 over 4. First of all, if we had mixed numbers, we'd have to change them to improper fractions. They are not improper fractions, they are proper fractions. Next, we would have to change any whole numbers into fractions by dividing them by 1. But again, they are all proper fractions. Now we multiply the numerators together. And we get an answer. 2 times 3 is 6. Then we multiply the denominators together. And here we get 5 times 4 is 20. Next up, see if we can simplify by pulling out a common factor. We can pull out a common factor of 2 from both. In which case, 3 over 10. Can we simplify any further? We cannot. Therefore, 3 over 10 is our final answer. As you can see, this is much simpler because there's no extra step of having to find a common denominator and potentially having to do prime factorization. Next up, we have 5 over 6, 7 over 8. Again, multiply the numerators, multiply the denominators. Here we get 5 over 7, which is 35, and 6 over 8, which is 48. Ask yourself, can it be simplified any further? It cannot. Therefore, that is the final answer. Let's try this one now. You can see we have 3 fractions here, and they're all being multiplied together. We just multiply the tops together, and we multiply the bottoms together. Very simple. So this would be 3 times 5 times 2, and this would be 7 times 9 times 5. You do not have to show me this step on any assessment, but I just want to make sure you can see exactly what I'm doing in my head. So we have 3 times 5 is 15, times 2 is 30. Here we have 7 times 9 is 63, times 5 would be 315. How did I do that in my head? 7 times 9 is 63. 63 times 10 would be 630. Well, 5 is half of 10, so I divided 630 in half, 315. If that confuses you, don't worry. You'll probably always have a calculator with you. We need to simplify this. Let's see what we can pull out. I can see I can pull out a 5 from the top and the bottom. We pull a 5 away from 30. We get 6. We pull a 5 away from 315, 20, 40, 63. There's 25s in every 100. That's why we went 20, 40, 60. And then 3 more 5s makes 15. And hopefully you can see this can be simplified down even further. 2 over 21. Can this be simplified any further? It cannot. Therefore, this is the final answer. Sometimes our terms can be canceled out early on, making it easy for us to simplify at the end. Let's try that now with the same problem. We'll combine those together. Now, if we have the same number on the top and bottom, we can cancel that out. You can see we have a 5 here, we have a 5 here. What we can do now, you could also pull out another factor here. We could break down the 9 into 3 times 3. And you can see we have a 3 on the top, we can have a 3 on the bottom. They also cancel out, giving me 2 over 21. Same answer. Later on, canceling is going to be key when we get to stoichiometry. So I want you to start getting comfortable with the idea of canceling terms out. If we have the same term on the top and the bottom, we can eliminate them. Why is that? Well, here, if we pulled that 5 over 5 out, what does that equal to? It's equal to 1. And if I had all of this times 1, it doesn't change the value at all. And that is the reason why things cancel out. Let's try some examples of multiplying whole numbers. First of all, we convert any whole numbers into fractions by placing them over a denominator of 1. We then multiply the tops, and we multiply the bottoms. Here we get 6 over 5. This here is an improper fraction. Convert it to a mixed number, 1 and 1/5. Final answer. Next up, we have 5 over 7 times 4. So the 4 is the second value here. Same rules apply. Turn it into a fraction by putting over a denominator of 1. Multiply the numerators. Multiply the denominators. 20 over 7. Again, we have an improper fraction. So we'll turn that into a mixed number. 2 times 7 is 14. Remaining is 6. So 2 and 6 over 7. Very simple, I think. Let's see how simple it is. I'd like to try some practice problems. There's a large number of them here. Give them a try. Some of them get progressively harder as we go. Let's take them up now. A, what do we have here now? 2 times 3 is 6. 5 times 4 is 20. We can now simplify this down. And we get 3 over 10. I think we had this one earlier, didn't we? Yes, this was our first problem. This one here, this is actually the second problem. We'll write that down. Let's look at C now. I'm going to show you 2 different ways to do this. First of all, we'll just use our standard method. Multiply the tops, multiply the bottoms. 3 over 27. Pull out a common factor of 3 now from the top and the bottom. And here we have 1 over 9. Final answer. Now, the alternative way to do this, let me write that down, is cancel out some terms. So you can see we have a 3 on the bottom, we have a 3 on the top. Remember, this would be one big term. This value cancels this value. It doesn't disappear. Be careful of that. Some students get rid of them and they make it 0. No, it's equal to 1. Now I multiply this one with this one, and I multiply this one with this 9. And here I get 1 over 9. Same answer, both here and here. 2 different ways to go about it. Let's try D now. Remember, you don't see a sign in between. You assume it means multiplied by. Let's see if we can cancel out terms. We compare the 18 and the 9. Yes, I can cancel 1 9 out of this and 2 9s out of that. So that becomes 1, and the 18 becomes 2. We compare the 3 and the 5. Can't do anything there. Here we have 2 times 5, and then we have 3 times 1. In the end, 2 times 5 is 10 over 3, and we get 3 and 1/3 as our final answer. Now, if the canceling out confuses you, don't worry, you can do it the original way. Multiply the tops, multiply the bottoms. 18 times 5 is 90, and 3 times 9 is 27. Pull out a common factor from the top and the bottom here. Common factor is going to be 9. And then 90 divided by 9 is 10, 27 divided by 9 is 3, and we get back to there. Both methods are correct, but you can see this one's much faster. On the test, I don't care which way you go, but if you're canceling out terms, you got to show me your work. Let's try E together now. Let's try E together now. Not too hard. Multiply the tops, multiply the bottoms. 2 times 5 is 10, times 4 is 40, 3 times 4 is 12, times 6 is 72. Common factor from 40 and 72. Let's take out 8. We can take out an 8, I think. Here we get 40 divided by 8 is 5, 72 divided by 8 is 9. Answer is 5 over 9. Let's do it the alternative way where we can cancel terms out. You can see we have a 4 on the bottom and a 4 on the top. So we take a 4 out of both of those. We have a 2 here, we have a 6 here. How many times does 2 go into 6? It goes in 3 times. How many times does 2 go into 2? It goes in 1 time. Now we have 1 times 5 times 1, and we have 3 times 1 times 3. 5/9. Both methods, absolutely acceptable. Let's try F now. Let's try and start by canceling terms out again. We have a 5 on the bottom, we have a negative 10 on the top. How many times does 5 go into negative 10? It goes in negative 2 times. How many times does 5 go into 5? It goes in 1 time. How many times does 12 go into 2? It goes in 6 times. How many times does 2 go into 2? It goes in 1 time. Lastly here, we can compare 21 and minus 7. How many times does minus 7 go into 21? It goes in minus 3 times. How many times does minus 7 go into minus 7? Goes in 1 time. So here, I can multiply these values together and these values together. 1 times minus 2 times 1 is minus 2. 1 times minus 3 is minus 3. Times 6 is minus 18. We have a negative on both the top and the bottom, so we can turn that into positive. And lastly, I can pull out a common factor of 2 from the top and the bottom, leaving me with 1/9. Final answer. Hopefully that's not confusing you. If that's confusing, let's go back and do it the original way. Multiply the tops, multiply the bottoms, and simplify. 2 times 10 is minus 20, times minus 7 is going to be positive 140. 5 times 21 is going to be 105, times that by 12, 1,260. So you can see we have quite a large number here. I had to use a calculator for that one. Now here we have 140 over 1260. We have a 0 at the end. One trick you can do, you can cancel out a 0 from the top and the bottom. In essence, what you're doing, you're dividing the top and the bottom by 10. This gives me 14 over 126. Let's pull out a common factor here. Let me see here now. Common factor here. I know 2 can come out. 7 over 63. We look at this now. Common factor from top and the bottom. In this case, is going to be 7. And here we get 1/9. Same answer, 2 different ways. Whatever way you choose is absolutely correct. Just make sure you show me your work. For G, I will just write down the answer. And if you have a problem with that, you can email me or contact me during the tutorial. Let's try H. It's got something a little extra. We have an exponent around a fraction. What do we do now? This is very important. You can see this fraction is inside the brackets. It is a single term. It is not separated by a plus or minus sign. As a result, because it's one term and one term alone, I distribute the exponent to both the top and the bottom. This becomes 3 squared over 4 squared times 4 over 12, giving me 9 over 16 times 4 over 12. Here, 9 times 4, 16 times 12. 9 times 4 is 36. 16 times 12, 192. We can pull a common factor out now. I know I can pull at least a 2 out of the top and the bottom. 36 divided by 2 is going to be 18. 192 divided by 2 is going to be 96. We can pull out another common factor here. I can see I can take a 2 out of the top and the bottom. 9 over 48. We can actually pull out one more common factor. We can pull out a 3. 3 over 48 divided by 3 is 16. Final answer. Many steps there to deal with. Alternatively, we could have done 3 over 4 times 3 over 4 times 4 over 12. These 4's cancel out. We take a 3 out of the 12, leaves us with 4. We take a 3 out of this 3, leaves us with 1. We now get 3 over 16. You can see this method is much faster. So ideally, work at this, try and learn this method, because this method is going to speed up your mathematics quite a bit. You can see here, when I cancel these terms out, I canceled out the 4 here. In essence, what I was doing is this. when I canceled out the 3 here, in essence what I was doing is this. Let's do one more together. I. Let's do it the canceling out method. What do we got here now? We have a 3 on the top, a 3 on the bottom. Take those both out. We have a 2 on the bottom, a 2 on the top. That makes 1 and minus 1. We have a 3 on the bottom and a minus 3 on the top, giving me 1 and minus 1. And here we have a minus 2, positive 4, giving me minus 1 and 2. Work those all out now. Leaving me with minus 1 times minus 1 times minus 1 is minus 1. 1 times 1 times 1 times 2, minus 1/2. Alternatively, let's do it the other way. 3 over 2 times minus 2 over 3 times minus 2 over 3 times minus 3 over 4. Multiply the tops. Multiply the bottoms. 3 times minus 2 is minus 6. Minus 6 times minus 2 is positive 12. Positive 12 times minus 3 is minus 36. On the bottom here now, 2 times 3 is 6. 6 times 3 is 18. And 18 times 4 is 72. Let's pull out a common factor from the top and the bottom. I can see I can pull a 9 out of the top and the bottom. Minus 36 divided by 9, minus 4. And 72 divided by 9 is going to be 8. One more time. Divide by 2, divide by 2. And here we get minus 1/2. Same answer as above. 2 different ways to get the same answer. The third possible way, we could distribute this exponent to here and here. Because this is one term, we can do that. This would be minus 2 times minus 2 is positive 4. And 3 times 3 is 9. So I could have put that in here in place of these values here. Hopefully you've been keeping up with the lessons. As you can see, these fractional questions are getting much more difficult. For J and K, you can see I have the answers here already. If you have any questions, you can contact me outside of class. Let's now try multiplying mixed numbers. When multiplying mixed numbers, we must first convert those mixed numbers into improper fractions, and then follow the standard rules for multiplying fractions. Here we take 2 times 4 plus 1 over 4. We're going to multiply 3 times 5 plus 2 over 5. 2 times 4 is 8 plus 1 is 9. 3 times 5 is 15 plus 2 is 17. Multiply the numerators. Multiply the denominators. 9 times 17, 153. 4 times 5 is 20. You can see this is an improper fraction. Let's see how many times 20 goes into 153. 7 times is 140. Here we have 13 remaining. 7, 13 over 20. Can we simplify this down anymore? We cannot. Final answer. B now. First thing you want to do is convert this from a mixed number to an improper fraction. Here we get 13 over 8, 11 over 4. Multiply the numerators, multiply the denominators. See how many times 32 goes into 143. 4 times. Here we get 4 and 15 over 32. Can we simplify that down anymore? We cannot. Final answer. Let's try a word problem now. Working in a lab for 7.5 hours a day for 22.25 days, how many total hours did you work? 7.5 hours per day. Remember, this is a fraction. I'm going to set this up as a fraction. 4, 22 and 1/4 days. In this case here, we're multiplying those together to get how many hours total you worked. First of all, convert those to improper fractions. I'm going to write my units here. I'm going to keep it as a fraction. Let's multiply my numerators together. And we'll multiply the denominators together. Notice here, we have some other numerators and some other denominators, the units. We can turn that days into a fraction if we wanted to by putting 1 underneath it. So here we get 15 times 89 is 1,335. We have hours times days. Over here, we have 8 days. Notice what we have. We have days on the top and days on the bottom. Just like numbers, they cancel each other out. Ideally, you'd cancel out those units here and here. Let's simplify this down. 8 into 1,335. How many times is 8 going to 13? 1 time. Say 6 times. And then bring down the 5, 55. We get 6 times. So here our answer is 166 and 7 over 8. What's our units? Look what's remaining here. Hours is remaining. Hours. Final answer. This is extremely important that you understand how to do this. Just like canceling numbers out if they're the same on the top and the bottom, because it's equal to 1, the same happens with units. And this is the basis of all of your stoichiometric calculations in chemistry. You must have the same units on the top and the bottom. If that is the case, those units cancel each other out. Very important. Lastly, therefore, you worked 166 and 7 over 8 hours. I'd like you to now pause the video and try this word problem. This is a great problem to start with. Here we have a formula. Volume of a rectangular prism, also known as a box, the volume is the length times the width times the height. And here we want to know what the volume of the rectangular prism is if it has this length in centimeters, this width in centimeters, and this height in centimeters. So give that a try now and see if you can determine what the correct answer is. So here is the correct number. Let's work through it together. So volume equals length times width times height. Let's go back here. Here we have the length is right here. The width and the height. So what we're going to do is substitute. We're going to take out the variable and we'll put in what the number is, and we're going to add the unit in as well. Now we have mixed numbers. First thing is convert them to improper fractions, keeping the units in there. Now that we have them all as improper fractions, let's multiply the numerators and the denominators to get our new number. Now, look at these centimeters here. You have centimeters times centimeters times centimeters. If I had 3 times 3 times 3, how could I express that? Well, remember, you don't see an exponent on here, but there is one. What we do, when we're multiplying exponents with the same base, we take the base as is, and we add the exponents up. So this would become 3 cubed. Same rule applies with the centimeters. Here is our exponents. Same base, therefore we add them up. This is centimeters cubed. That's where the centimeters cubed comes from. It comes from the math. That's why it's so extremely important in science that we leave our units in our calculations. Don't just use the numbers if there's units in there. Put your units into your calculations. We're not quite done yet. We now have to simplify this down. Let's find out how many times 36 goes into 805. So here, this becomes 22 and 13 over 36 centimeters cubed. Cannot be simplified down. Therefore, the volume was 22 and 13 over 36 centimeters cubed. Make sure those units are in there with it. Here's some practice problems for you to try. Please pause your video and give them all a try. A, B, C, D, E, F, G, and H. Again, if you don't do math, you won't learn math. I'll write down all the correct answers, and I'll take up some of the more challenging ones. Okay, let's take up a couple of them. Let's take up B. Here, first things first, let's convert our mixed numbers into improper fractions. 2 times 4 plus 3 over 4 multiplied by, be careful of the negative sign here, 1 times 2 plus 1 over 2. I'm keeping it outside that fraction itself to indicate the whole thing is negative. Perhaps if you got this wrong, that's what you did. Let's now do the math on that. 2 times 4 is 8, plus 3 is 11. 1 times 2 is 2, plus 1 is 3. And then 2 times 3 is 6, plus 1 is 7. There you go. Multiply the numerators. Multiply the denominators. Before we do that, let's see if we can simplify. I have a 3 in the top, a 3 in the bottom. I can take 1 out of both of them. And that's all I can simplify. But it makes my job a lot easier. 77 over 8. No need for a calculator. Notice there are 2 negative signs, an even number. Therefore, this fraction will be positive. How many times does 8 go into 77? Goes in 9 times. 9 over 8. 9 times 8 is 72, so we have 5 remaining. Final answer. Let's take up H. That looks like a challenging one. First things first, convert them all into improper fractions. Again, watch out for that negative sign. 13 over 4, 10 over 3, negative, 2 times 6 is 2, plus 1 is 13 over 6. Can we simplify anything down here? Yes, we can. I can take a common factor out of 4 and 10. I can take a 2 out. How many 2's come out of 4? 2 come out. How many 2's come out of 10? 5 come out. Made things a bit easier. Still quite a challenge. Probably need a calculator. 13 times 5 times 13. That's going to be 845. And then we have 2 times 3 times 6. 2 times 3 is 6. Times 6 is 36. Here we only have one negative sign. As a result, this fraction is negative. How many times does 36 go into 845? I'm going to say twice there. 72. Bring down the 5. How many times does 36 go into 115? 3 times. 3 times 6 is 18. Carry the 1 and 10. There we go. That's 7. So here we have minus 23 and 36 over 7. Challenging one. I like the challenging ones. They're more fun. That is the lecture on multiplying fractions. You can see it's quite simple. You multiply the numerators, whatever number you get becomes the new numerator. Multiply the denominators, whatever number you get becomes the new denominator. That seems simple. Then we throw in mixed numbers. Remember, convert all those numbers over to improper fractions first. Where possible, try and cancel terms out early on. Otherwise, there's a lot of numbers you'll have to simplify at the end because, once again, we are multiplying now. The numbers are going to get quite large. If you have any questions regarding the questions I did not take up, please do email me or contact me during tutorial. That's all for today. Until next time.